Okay, so we're going to begin chapter 12 and we're going to talk about evaporation. So we'll say that we have a container of water or any liquid. And we are going to have molecules that are near the surface. There's other molecules which would be below this. But for right now, we're going to focus on these particles that are right at the surface. So we know that each one of these particles, they don't all move at the same speed. So the speed and the kinetic energy then of these particles is different. So let's say that we have a particle here near the surface and it has more kinetic energy than surrounding particles. In fact, let's say it has enough kinetic energy that can escape the surface of the liquid. And maybe there's another one over here that has enough kinetic energy that it can escape the surface of the liquid. So those particles that have high kinetic energy will overcome the forces that hold these molecules together and they will escape the surface of the liquid. And this is called evaporation. And it happens at the surface of a liquid. Now, because these higher kinetic energy particles are leaving the liquid, that means there's less kinetic energy left in the liquid, and because there's less kinetic energy, those particles move slower and therefore will have a lower temperature. So evaporation results in cooling. And it's a cooling process, like I said, because those higher kinetic energy particles are leaving. Therefore, the liquid that is left has less kinetic energy. Now, the rate of this evaporation can vary depending on some factors. Okay, the first one is temperature. So if we heat that liquid up, that means we're giving it more energy, which means there's going to be more particles that are going to have sufficient energy to escape the surface of the liquid. Okay, the second factor is going to be surface area. Because this evaporation is happening at the surface of the liquid, if we have a larger surface, then we should have more evaporation. And the third one is called intermolecular or interparticle forces. And these are the forces that hold the molecules in the liquid together. So intermolecular forces are kind of like glue. So if we have one water molecule, and let's say we have another water molecule, this is going to be some glue that holds those molecules together. So the stronger the forces are that hold these molecules together, the harder it is for them to evaporate. So if we have a liquid that has fairly weak forces, that means there's going to be a greater rate of evaporation. Okay, now at the same time that we have evaporation occurring, we are also going to have some vapor. So here's our vapor. This is the gas that is present. Some of these gas particles have less kinetic energy, and therefore they are landing on the surface of the liquid. So maybe there's another one here, and this one's going to land on the surface. So those particles that have less kinetic energy are going to land on the surface of the liquid. And that is condensation. So molecules with less kinetic energy will land on the surface of the liquid. And because condensation is the opposite process of evaporation, if evaporation is a cooling process, then condensation is a warming process. And you know this to be true. If it's very humid outside, there's going to be a lot more condensation occurring on the surface of your skin. So it is very hard for you to cool down. Now, normally our body tries to cool down by sweating, because when we sweat, there's going to be moisture or liquid on our skin. That liquid would evaporate, and that would be a cooling process, leaving our skin cooler. But in the summertime, when it's very, very warm and there's a lot of moisture in the air, we're having more condensation, so we're getting more warmth as we're having more condensation on our skin than we are evaporation. Now, if we have that container and we have the rate of evaporation is the same as the rate of condensation. So when that happens, and I have just as many particles leaving the surface as are landing on the surface, this is called equilibrium. Okay, the book refers to it as dynamic equilibrium. Okay, and that's when the two rates are equal. Now, if we have a closed container, okay, so we'll put a lid on our container. In that case, the rates are going to be equal, and this is going to be at equilibrium. So there is going to be some gaseous particles up here, that vapor, and that vapor is going to exert a pressure on the liquid below. And this is called the equilibrium vapor pressure. P is our pressure, so a lot of times you'll see it P sub vape for the equilibrium vapor pressure. And that is the pressure that the vapor, or the gaseous particles, exerts on the surface of the liquid. And this equilibrium vapor pressure is going to vary from substance to substance. It's also going to vary with the external pressure, and it's going to vary with our temperature, and it's going to vary with our intermolecular forces. So if we have strong interparticle forces, that means we said we had less evaporation. So if there's less evaporation, there's going to be less vapor and therefore less vapor pressure. If we have a high temperature, we said that that meant there was going to be more evaporation. And if there's more evaporation, that means there's more vapor and therefore a higher vapor pressure. All right, and that finishes up section 1.